Hello everyone, welcome to Neelam tutorial, and in today's video here we are to deal regarding one of the very important chapter of organic chemistry, that is aldehyde and ketones. So most important equation right in the chapter is Rosenmund reduction. Next you have ozonolysis. You might have seen ozonolysis as a repeated question. Ozonolysis method can be used for the preparation of both aldehyde and ketone. So this method is basically used for the preparation of aldehyde and ketone from alkene. Next, you have distinction between. So how can we identify whether the compound is aldehyde or ketone? So very first is that is we have 2,4-DNP test. So 2,4-DNP test is usually used to identify carbonyl compounds. That is, it will help us to identify whether from the group of compound whether it is aldehyde and ketone. So basically, we can get identified this from that. Next, Tollens reagent test is basically only for the aldehydes. So this test is Tollens test is only for aldehyde. Okay, only for aldehyde, not for ketone. Okay, and this one Felling's test is only for aliphatic aldehyde. Aliphatic aldehyde. Mean if we have a carbonyl compound and if we test it for the first one, that is 2,4-DNP test, and if both the test comes positive, then we come to know that it is aldehyde or ketone. Next, if we'll do Tollens test and if it gives positive, we'll come to know it is aldehyde. If it gives negative test, we come to know it is ketone. Then when we become sure that it is aldehyde, and if we need to identify whether it is aliphatic aldehyde or aromatic aldehyde, at that time we generally go for Fehling solution test. And Fehling solution test exactly help us to identify only the aliphatic aldehyde. Tollens reagent test exactly help us to identify aldehyde. And the 2,4-DNP test help us to identify. This basically help us to identify carbonyl compound. So it helps us to identify carbonyl compound. Carbonyl compound. Okay, so let's move on for the very first one, that is your Rosenmund reduction reaction. So what exactly is Rosenmund reduction reaction? So so basically what we need to understand over here is when you have acid chloride. So when we have acid chloride, that is RC double bond OCl, and if it is being treated with a hydrogen in the presence of PDBaSO4, that is Rosenmund catalyst. We also call it as Rosenmund catalyst. Okay. So basically what is that is when acid chloride is treated with hydrogen in the presence of PDBaSO4, it will give us R C double bond O. This Cl group will be removed and the H single bond H bond will break and one of the H will come over here and another H will take away the Cl. So here we'll have H and here will be the liberation of HCl. So here we get aldehyde. Okay. So what is it exactly? So we need to understand when acid chloride is treated with hydrogen in the presence of PDSBaSO4, aldehyde is formed. What is PDBaSO4? So PDBaSO4 is Rosenmund catalyst. So we generally get aldehyde, and this method of preparation is known as Rosenmund reduction reaction. Okay. Now what next we have over here is, let's take an example and explain it. So over here we have CH3 C double bond O Cl, and we treated it with hydrogen in the presence of PD and BaSO4. Okay. So what we got is again this Cl is being removed, and here will be the formation of CH3, C double bond OH, along with the liberation of HCl. So this is your ethanol. Here we were having acid chloride, or we can call it ethanoyl chloride. Okay. When it's treated with hydrogen in the presence of PDSBSO4, it gives us ethanol. Okay. Next we have ozonolysis reaction, one of the very important way of preparation of aldehyde and ketone. So next we have ozonolysis of alkene. So this basically goes in two steps. Ozonolysis of alkene basically goes in two steps. So if you have an alkene, that is, there you have carbon, double bond carbon. And other than that, right now I'm just keeping a blank bond. And if it is being treated with ozone in the presence of carbon tetrachloride, that is CCl4, what will happen is you need to keep in mind that this ozone group will come and attach right at this point. The double bond between the two carbon will break, and this will be something like this. It will be like C, and this 2 I'll keep it as it is, this 2 I'll keep as it is, and this double bond will be removed. In between, what am I going to insert is O, no. You need to just remove the double bond. Wherever is the double bond, you need to remove it. And instead of that double bond, you need to put this 3 oxygen in this manner. Now what will happen is the bond will break in the presence of when we treat this compound with further with the zinc dust and water. What will exactly happen is the bond will break in this manner. The bond will break right from this point. And what will happen? This bond will shift over here. This bond will shift over here. And there will be the formation of double bond. And the product those formed will look like this carbon double bond and the two blank bonds. Again, there will be carbon double bond oxygen and two blank bonds. So exactly there will be the formation of aldehydes or ketone. So this can be aldehyde or they can be ketone. So basically what you need to remember, when alkene is treated with ozone in the presence of, so what we were having in the beginning, we were having alkene. It is treated with ozone in the presence of carbon tetrachloride. So what is ozonolysis reaction? Alkene is treated with ozone in the presence of CCl4. We get ozonide and an intermediate, which is further being treated with zinc dust and water to form aldehyde or ketone. Or either both aldehyde group will be formed or both ketone group will formed or one aldehyde and one ketone will form. Let me explain you all this with the help of some example. Right? Example hero है ना? Example का आधार में explain करेंगे. Examples. So let me take an example of CH3, CH double bond CH2. So I'm treating it with ozone, in the presence of carbon tetrachloride CCl4. Okay, so I already asked you what will happen is instead of this double bond, what you need to insert? You need to insert this ozone. You need to insert this ozone right there. So what is gonna form is CH3, CH, you remove the double bond, CH2, and here we will have O, and O group. Okay. So what will happen is the bond will break. Again, what are we going to do is we are going to treat this with zinc dust and water, zinc dust and water. So the bond will break right from this point, and this point. So it will shift here, it will shift here, and it's gonna form something like this: CH3, CH2. Sorry, it will be something like this: CH3, C double bond O, H, and next we have CH2. Means C will have two hydrogen and double bond oxygen. That means there is a formation of ethanol and methanol. Okay. So here we were having propane, and here we have ozone being treated with, in the presence, alkene being treated with ozone in the presence of CCl4, which is further being treated with zinc dust and water to form two molecules of aldehyde. Let me show you some other examples. There we have CH3, C, CH3, double bond CH, single bond CH2, sorry, CH3. I have this type of compound. I'm treating it with ozone and the presence of CCl4. So you already clear. Again, what am I going to do? Instead of double bond, I'm going to insert this ozone. So what will happen? There will be the formation of C. It will have two CH3 group. Okay, let me write it a little bit differently. I'll have the carbon. It has two CH3 groups, CH3, CH3. The other carbon has one hydrogen and one CH3 group. Okay. In between, what I need to insert? I need to insert the ozone molecule, O, O, and O. Okay. So this will be something like this. Further, what will happen is if I'm going to treat it with zinc dust and water, the bond will break from this point, and this point. It will shift over here, and this one will shift over here to make double bond. And the product will formed will be CH3, C, double bond O, CH3. And the other I'll have is CH3, C double bond O, H. So this is your propanon. Okay. Next you have it and ol. So the very first one we were having is 2-methyl bute 2-ene being treated with ozone in the presence of CCl4. So here in this reaction, you can visualize that when alkene is treated with ozone in the presence of carbon tetrachloride forms an intermediate which is further being treated with zinc dust and water to form a ketone and an aldehyde. So this reaction is known as your ozonylysis reaction. So here we have a formation of ketone. Here we have a formation of ketone and here we have a formation of aldehyde. So by this method, basically we can prepare both aldehyde and ketone. Next, we have a method for the preparation of distinction between aldehyde and ketone. So method used for the distinction between aldehyde and ketone. Aldehyde and ketone. So the very first technique that we have right in this one is 2,4-DNP test. In this we have the very first one that is your 2,4-DNP test. So this method is basically used for the identification of carbonyl compound. Basically किसी भी organic compound में C double bond O group है या नहीं है उसको identify करने के लिए we generally use 2,4-DNP test or we also call it 2,4-dinitrophenyl 2,4-dinitrophenyl hydrazine 2,4-dinitrophenyl hydrazine test. Okay. So what exactly is 2,4-dinitrophenyl hydrazine? So that you might be clear. You need a phenyl group. That means you need a benzene ring. Right in the carbon number 1, there should be hydrazine. So hydrazine is NH, NH2. and 2,4-dinitrophenyl. So at the position 2 and 4, there should be 2 nitro group. So this is your 2, 4 dinitrophenyl. So this is 2,4-dinitrophenyl hydrazine. Sorry, I missed hydrazine. Hydrazine. Okay. Now let's move on for the reaction, that how it identifies whether the given compound is aldehyde or ketone. So the very first reaction, let's take an example of aldehyde, that I have CH3, C double bond O, H, and it is an ethanol or aldehyde. What is this? It's an aldehyde. I'm treating it with 2,4-dinitrophenyl hydrazine. So this is my phenyl group. I have a hydrazine group being attached right at this point, and H and H2. Okay. Next, I have two nitro group at carbon number 2 and 4. Okay. Now, what will happen is the two hydrogen from hydrazine and the oxygen from the carbonyl group will make a bond and liberate in the form of water. Now, what will happen is this C double bond O will make a linkage exactly with this nitrogen, and the compound those formed will be CH3, CH, double bond N, NH, and here you will have a benzene ring containing two nitro group. Okay, so this will be the product along with the liberation of one molecule of water. So the product those formed is acetaldehyde, acetaldehyde because this part was acetaldehyde, and the remaining part is what you already know, 2,4 dinitrophenyl hydrazine. Sorry, it's hydrazone. 2,4 dinitrophenyl hydrazone. Okay, so basically did the reaction. It is generally used for the identification of carbonyl compound. Along here, you have the liberation of water as well. Sorry, I rubbed it. Next, let's take an example of ketone. Let me take an example of ketone. Acetone, let me take it. C double bond O. We have two CH3 group attached right with it. Again, let me take 2 nitro, 2,4 dinitrophenyl hydrazine. Phenyl group containing two nitro group and a hydrazine, that is NH, NH2. Again, the same reaction will take place. The H2 will take away this two oxygen, and there will be the formation of product which looks like CH3, C, CH3, double bond N. Again, you have an H having a benzene ring and two nitro group being attached with it. Two nitro group being attached with it. So the product those formed will be acetone because we already know that this part is your acetone. So here you have acetone, and other than that you have 2,4 dinitrophenyl hydrazone. Okay, it is an orange color dye, orange dye. So basically this method is used for the identification of carbonyl compound, and it is also known as DNP test. 2,4 DNP test, or simply we call it DNP test, used for the identification of carbonyl compound. Let me go for the next one, that is your Tollens reagent test. Tollens reagent test. So sometime what happen is question is directly being asked that what is Tollens reagent. So that might also be your question, that what is Tollens reagent? Tollens reagent. So Tollens reagent is your ammonical solution silver nitrate of silver nitrate. So it's basically being written as AgNH3 2 OH. So what is Tollens reagent if the question comes? You will have to say AgNH32OH, or you need to say ammonical silver nitrate solution. Okay. So this is your Tollens reagent. Now what will happen when you are going to treat it with aldehyde? Basically, it is used for the identification of aldehyde. Used for identification of aldehyde. Okay. So let's move on further for it. So if I have an aldehyde group, that is R CHO group, and if I'm treating it with Tollens reagent, that is AgNH3 2 OH, they will react together to give a carboxylic acid RCOOH, along with the liberation of two molecules of Az, or silver mirror we can call, along with the formation of NH3 and H2O. So here we have silver mirror will be formed. Silver mirror. So we also call it silver mirror test. Tollens reagent test is also known as silver mirror test. Silver mirror test. So question can be Tollens reagent Tollens reagent test is also known as, you will have to say, it is also known as silver mirror test or Tollens reagent test. What is it? So it is AgNH32OH, ammonical silver nitrate solution. What will happen? So it will react with aldehyde to give carboxylic acid, ammonia and water, along with the liberation of silver, which comes in the form of mirror, and hence the test is known as silver mirror test. And this test is positive only for aldehyde and not for ketone. The test is negative for ketone. Okay, you'll not have any positive test for ketone. You'll have one test only for aldehyde, but it can be used both for aliphatic and aromatic aldehydes. Let's move on for the last one. For this video, we have Felling's solution test. Felling's solution test. So what exactly is Felling's solution test? So let me first make you know what is Felling's solution. First, you need to understand that what exactly is Felling's solution. Felling's solution. So Felling's solution is basically alkaline solution of copper sulfate. So this is alkaline alkaline solution of copper sulfate containing sodium potassium tartarate. So in this we have sodium potassium tartarate. Okay. So basically, if it comes, I don't think it will come, but still then you need to know. So what is Felling's solution? It is alkaline solution of copper sulfate and which is in which some sodium potassium tartarate is being added, and it looks something like this. Felling's solution, basically, if you go for the molecular formula, you will visualize it in this way. Okay. So it looks like Cu having bond with the two oxygen, which is being connected with the two other CH group. They are connected like this. In one there you have COONA and the other you have COOK. So this is basically your Pelling solution, or the mixture of alkaline copper sulfate and sodium potassium tartarate. Okay, now let's move on for the reaction. What exactly is this? So when you have an aldehyde group, RCHO, and if it is being treated with Pelling solution, from here we only use Cu2 plus ion, copper ion, and hydroxyl ion. During reaction, we only write this. Okay. So when it is treated with Pelling solution, we got these ions from Pelling solution. Okay. We got this from Pelling solution. So they will react together to give RCOOH along with the formation of Cu2O, which is reagent precipitate, along with the liberation of water. So basically, this is our target thing. As soon as there will be the formation of Cu2O, it is a red color PPT, and we come to know that the given compound is aliphatic aldehyde. So used for the identification, this test is used to identify that the given compound is an aliphatic aldehyde. Aldehyde. Okay. So basically what you need to understand when aldehyde, basically aliphatic aldehyde. So this need to be an aliphatic aldehyde for sure. You need to take aliphatic, aliphatic aldehyde. And if you treat it with, so what we have aliphatic aldehyde. And if you are treating it with copper and hydroxyl group, that is Pelling solution, it will give red precipitate, that is Cu2O. And that is the positive test for aliphatic aldehyde. And the test will be negative for aromatic aldehyde and ketone. So that's it for today. If you will have any queries anywhere, do mention it in the comment section so that I can reply you in the next video. Also, I'll attach some of the related question right in the comment section or in the description box. So kindly do that. And if you are able to do, kindly put it in the comment section so that it will help your other friends. Also, if you like it, do share it with your friends. Thank you.